Today we have Andony Melathopoulos and Ellen Silva. Andony has incredible experience, and he specifically reached out to me to join in this webinar, and I'm so happy that he's here today. He's an assistant professor of pollinator health extension in the Department of Horticulture at Oregon State University. He has over 15 years of experience working together with commercial beekeepers, land managers to develop solutions for healthy bees in Oregon. So we're excited to have him here today. Also Ellen, she's a retired engineer and is a recent Oregonian who's moved here to be with family, and she's a bee enthusiast who's also worked with this program. So that's what we're going to be jumping into today. And I also want to just give you a little background for Zoom webinar. We can't see or hear you. You're going to have to put any comments or questions in the Q&A chat box. And at the end today, we're going to answer all of your questions at the last kind of like 15 minutes. So if you have any questions as you're going, Facebook or Zoom, throw those in there and we'll get to those at the end. So with that, I'm actually going to hand it over to Andony and Ellen, who are going to jump in and talk to us about the Oregon Bee Atlas. So once again, so excited to have you two here. Thanks.
Thanks so much, Tiffany. And it's a real honor to be speaking to the Johnson Creek Watershed Council in the Community Education Series. It's very impressive what all the volunteers of the council do. And I really appreciate the opportunity to tell you a little bit about a project that we're doing that is statewide. Now, just to make this run a little bit more interactively, we do have some questions in here, and you can answer these questions. Not mandatory, just make it give me a sense of who you are. And I guess the first question I have, and the way you can answer these questions is if you hold your phone up to that barcode, it will, and turn your camera on, it will bring up this URL, and there will be some polling questions there. And as we go along and we see some bees, we'll be able to get a sense of what you know already. And so I'm going to just do it with my phone to begin with. Hopefully this isn't too complicated. All right, I'm going to do myself. I'm holding my phone up, and then for all subsequent questions, it'll just show up in the same place. Now, I have heard about the Oregon Bee Atlas. Yes. Okay, there we go. Well, there's a number of people here who have. I'm very surprised. That's wonderful. It's good to know. So this may be a little bit of a refresher, but there's a lot of moving parts to the Atlas. So I'm going to advance to the next slide. This is what I'd like it to do today. First of all, I would like to address the question of why an atlas. Next, I'd like to go to how does the atlas work? Then I'm going to hand things over to Ellen. She's going to talk about the bees of the Johnson Creek Watershed, and I'm going to end off with how you can help. So why an atlas? Now, the thing to keep in mind is that people haven't always been concerned with bees. If I took you back, let's say to the 1980s, there was back in the 1950s, there was an introduction of honeybees from Africa, from Eastern Africa population that spread and then came into Central America in the 1980s. This prompted a number of horror movies about bees. You can see there's an ABC miniseries there, and The Swarm, which had an outstanding, it was Michael Caine, Catherine Ross, Henry Fonda, and you know, the kind of, if you were to talk to anybody about bees, their general response to you is, I've been stung once. Now this changed, really changed about 15 years ago. There was a situation with honeybee colonies. Many of you, I'm sure, have heard of it. Colony collapse disorder. We're looking at 3 frames from a honeybee colony. In the middle, you can see those little brown cappings. That's the immature bees. And beekeepers found this time of year, they'd look in their colonies and many of the adult bees had disappeared. Now, the situation with honeybee colonies, you know, they're not disappearing anytime soon. This is a graph of the number of honeybee colonies in the United States. You can see they were at a high point in the late 1980s. At that point, there was a price support program that was eliminated and the colonies came down. And you can see on the hash line 2006, that's when colony collapse disorder occurred. and somewhat of a low point, but you can see the honeybee colonies have recovered in numbers since that point. And this is not to say that beekeepers don't suffer from high levels of losses to their colonies. They can make those losses up. And one of the big concerns that beekeepers have, you can see this honeybee in the bottom left-hand corner. She's got a little red dot right on her abdomen right here. That's a mite. And these mite parasites came in somewhere in the late 80s and have been very difficult for beekeepers to manage. But beekeepers are ingenious, and they have been able to keep the colony numbers rather steady in the United States. We now know the reasons why it's been so hard to keep honeybee colonies. It's not just these parasites, but also there are other factors. One factor is nutrition. The swaths of forage of flowering plants in the landscape have started to diminish in a place like Oregon, for example, in the agricultural areas where once there was clover seed, fruit crops, we're seeing things like wine grapes, hazelnuts that don't really have much benefit to bees. The other thing with honeybees in particular is that they're increasingly, their income beekeepers are getting is from renting their colonies for crop pollination, which puts them in direct exposure with the number of pesticides that are used to manage those crops. And one issue that is quickly becoming a pressing concern is climate change. As you know, here in Western Oregon, we're increasingly having dry, hot summers, and it gets very difficult for bees to find any forage in a situation like that. But the issue does not extend just to honeybees. So here in Western Oregon, maybe 2 decades ago, you'd be able to see this bumblebee roaming through the landscape. It's distinctive because it's the only bumblebee with white hairs on its tail. This bumblebee has experienced a dramatic range reduction. You cannot find it in the valley anymore. You need to go up to the Cascades and east of the Cascades to be able to locate it. And in Oregon, the issue around bees really came to a fore, not around honeybees like in other states, but around bumblebees. If some of you remember, 2013, there was a series of publicized and kind of horrifying bumblebee poisonings that occurred. This one, the most visible one, was on National Pollinator Week at a Target parking lot. And this prompted the Oregon Department of Agriculture to ban these chemicals on these shade trees. So I believe it's still one of the only states where these 4 chemicals are not allowed on the shade trees. We haven't had an incident since on these shades. But this prompted the legislature to look more carefully at pollinator health. And in 2014, there was a Pollinator Health Task Force, which led to this law, which created essentially my position, but also a comprehensive program around pollinator health in Oregon, which we call the Oregon Bee Project. This is a collaboration between Oregon Department of Agriculture, Oregon Department of Forestry, and OSU Extension. And here you can see Representative Jeff Reardon from Happy Valley, who sponsored the bill with staff. I'm in the back there, but also staff from ODA and ODF. Basically, this plan looks like this. There's a lot of investment and effort that has gone into training and educating everybody from pesticide applicators to gardeners to the public on pollinator protection. There's been the development of decision-making support tools like these cards. They're handed out in the thousands to people, just showing them what the best practices are for managing landscapes in Oregon with pollinators. We've been highlighting innovators who go an extra step towards pollinator protection in the state. But what I want to talk about is the 4th pillar. If we did all those 3 things correctly, we should be able to see some kind of improvement in our wild bee populations in Oregon. But the problem is we have no way of measuring that. So a key aspect of the Oregon Bee Project is the Oregon Bee Atlas, which is our native bee survey. The importance of doing this is outlined in this episode of a podcast we have at OSU called PolliNation. We have John Asher here, who's from the National University in Singapore. He sort of oversees inventory of bees of the world. He says if we want to understand what's happening with bees, we have to be a lot more specific. We need basic maps of where bee species live in relation to habitat and ecoregions. And this is being done increasingly where people take records of bees that they've found. And this one is done, you can see here, this is from 2011, and be able to model what's going on with bee populations over time. In Oregon, this is a very difficult task because we really don't have a full inventory of the bees of our state. We don't have something like this, which has been an inspiration to us. Oregon Flora. If some of you have seen Oregon Flora, you can pick up this book, and the second edition has just come out. Open it up to a page, and you can find any species there. And on that page, you can see spots of where it's been spotted and where its estimated range is. And if you go to the Oregon Flora right now, to their brand new webpage, they've got a great digital online way to visualize this. We don't have anything like that for the bees of Oregon. But how hard could this actually be, coming up with an atlas for bees? I mean, we have roughly the same, we think, roughly the same number of bee species as we have bird species in Oregon. We estimate we have about 600 species of bees, and there's 537 species of birds. To get at this, I'm going to show you a picture of 9 critters. Take a look at these 9 critters, and I'm going to ask you a question with that little polling app that we used earlier. How many bee families you see? So carefully look at them, look at their faces, look at their butts, look at their legs, look at their wings. And in a second, I'm going to bring up a poll. I'm going to ask you how many families. Now, you may be out there scratching your head saying, what do you mean families? What I mean is the insects, a family is a taxonomic unit. So insects are at this very high level unit called a class. The bees, wasps, and ants are a subset of the insects, and they're in this group called an order. And the bees are not quite a family, but they're a superfamily, and within there's a number of families. And so you could imagine, for example, here we have the Adrenidae, it's a family, and at the the genus Adrena, you can see there's 3 critters in the family, and in this genus there's 2, and the species there's 1. We've kind of worked our way down. So with that in mind, a crash course on biological taxonomy, I want you to tell me, how many bees did you see? Did you see, were there 0 bee families or all the way up to 6 bee families? I'm going to try it myself. Oh, your polling will go all the way up to 9, actually. What if 0 means that none of those were bees? I fooled you completely. And 9 means actually every one of those bees was from a different family. All right. Oh, good. Thank you for voting. And for those of you who joined late, you just hold your camera up to that QR code and it will generate a link, and then you can go and pull from there. Oh, I see somebody said 9. That I've been very tricky here, and on the other, there's a few people in the middle. Nobody selected 0, so. Oh, look at that spread. That's fantastic. Okay. With that in mind, I'm going to move us to our next. So the vote was for 4, which is very close, actually. And the real answer actually is 3. So here we go. Here they are. There are 9 critters. And I'm going to show you the families now that are represented here. The first family goes all the way from this rather buff bee down to this slender bee. is the family Adrenidae, which includes 250 species, including, and I would encourage you, if you're in Portland, if you go to the Hoyt Arboretum just across from the zoo parking lot in about a month or so, and you walk across the lawn like this gentleman, what you're going to see is these little mounds of dirt. And this is these are our mining bees. So you can see them here. Each one of these mounds is a different nest. It's a very beautiful nesting site over by the Arboretum. And there's the bee there. She is headed down into her tunnel. I'm just curious, if you do have your polling, have any of you ever seen these mining bees make a nest in your area? Okay, no. This is great because they will be prolific. I honestly, if you go for a walk in about a month or so and look at some lawns, especially ones that are a little bit unkept, you will start to see them. And I see there's a portion of people who have seen them, and some people aren't quite sure. That's great. Fantastic. Okay, great. So a lot of you, I promise you, you will see them. There's one genus that's one species that's very, very visible in urban areas. What you'll see is you will see this dirt mounded up at the top, and it will appear for about 3 or 4 weeks, and then it will disappear. And what's happening is the female's going through, she digs this channel, and then she collects the pollen from the flowers. You'll often see them on those little daisies that you get on the lawn. They'll collect the pollen, they'll roll it into a ball, and then they'll lay an egg on each one of those pollen balls. She then backfills the channel, she goes off and dies, and under your lawn, these bees they're not doing any damage, they're just developing and eating that pollen until the next year. All right, here's the other group. You can see how variable this group is. You have bees that are all black. You have one here that's very yellow and black striped. You can see the difficulty in identifying these bees and figuring out who they are. They look, even ones that are taxonomically related, don't look alike. And let's look at this bee here because it's a real success story in Oregon, this one with the yellow and black stripes. There are farmers in Eastern Oregon. This is a native bee. There are farmers who grow alfalfa seed in the eastern part of the state who have figured out how to create the nesting conditions for this bee. Here's one of the females. They're solitary bees. They make their own nests. So here's 2 females side by side building nests. And there's a whole bunch of nests. What the growers have learned is these bees like these alkali flats. So they run a little pipe underneath the nests. They put pounds of salt to get that crusty soil at the right condition. And then the bees just flock and build up these huge nesting aggregations that then go forward and pollinate the alfalfa. Last, we have the last family are the Megachilidae. This group is very variable in the way that it looks. But one thing is characteristic, and you'll see it in this little video from a Shasta daisy. These bees, unlike any of the other bees, carry the pollen underneath their abdomen. So you can see this bee, she's going across the Shasta daisy, and the pollen is accumulating on her belly. This whole family has that characteristic. Another characteristic of these bees is they tend to build their nests above ground in cavities. In nature, this would mean a pithy stem. You can think of something like a spirea bush or something like that, where the stem is hollow in the middle. But you can also get them to nest in just any kind of hole, a wooden block, for example. The bee that's, I think, very well known are the leaf-cutting bees. These bees will cut little segments of the leaf from a very specific plant. They put the pollen in that little leaf container. They lay an egg. They wrap it up with another leaf disc, and they just continue making these cells. On the top, you can see here's a bee that actually uses pulp. So not leaf disc, but she's pulping up the leaf and creating these little pulp nest cavities. The other bee in this group that is very well known that's going to be flying shortly is our mason bees. This is Osmia lignaria, one species of the mason bees. And here you can see here's a hollow stem. She's lined the stem with mud, and there's the pollen inside where she lays an egg. And here you can see her just finishing off that nest by putting a mud plug on the outside. I'm just kind of curious, does anybody out there maintain mason bee nests? We're looking forward to keeping their mason bees this year. Oh, good. Nice to see there's a number of you out there. A large number of you, almost 70% of you are keeping mason bee nests. That's fantastic. So just to return to the prompt, how hard could this be to identify these bees? Well, it's actually exceptionally hard. They all look alike. You need microscopes, and you need somebody who actually can tell the difference between the bees, because the actual process is not that intuitive. And this may be the reason, this is a study that was done recently, where why we haven't really had any inventories of the bees. So what you see here is a graph of the continental US, and they've included in this graph the studies that were of any kind of size. So there's always people looking for bees, but here they've kind of restricted it to studies that have sort of turned up 100 species or more. And what you'll notice, two things: the size of the circle is the size of the dot is the area that was surveyed, and the color of the dot is how many species have been identified. You can barely see the dots east of the Mississippi. They're very pale. That's because there aren't a lot of bee species east of the Mississippi. Our bee biodiversity is concentrated in the West, and it is concentrated in the arid parts of the West. But as you can see in Oregon and the Pacific Northwest, maybe there's been 3 comprehensive assessments of the bee fauna. That really does not give us a sense of what's going on. And some of these studies, these are the actual studies that are listed, go back a long ways. For example, there's one here from the 19th century. And in fact, when we go back and look at some of the bee records in Oregon, many of them are very old. In fact, this is the last checklist we had of the estimated bee species of the Pacific Northwest, and it's from 1969, a long time ago. And the reason this is hard is Oregon is exceptionally difficult to survey because we have a really diverse biogeography, and the bees that you find on the west side of the Coast Range are very different from the bees that you find east of the Cascades. And we have these remarkable pockets of high plant endemicism, plants that are specific to a region that make the state very, very different. One part of the state different from the other part of the state. And so we took inspiration when thinking about how to solve this problem from a very old approach. This is Charles Robertson. He was the son of a druggist, and just happened to let his interest in being a natural historian flourish. He worked independently, and he was the person with that record of, person who kind of did these in-depth studies in the 19th century. And he did this in just northeast of St. Louis. And he had these very detailed records of which flowers bees were going to. And this is one of the richest data sets we have, because it's not only of the bees, but it was also of the flowers that they were going to. And this level of detail and this kind of amateur, what I mean by amateur is not somebody in the university, approach really inspired us. So the Oregon Bee Atlas is about taking people who are not professional entomologists and empowering them and making them able to go out and make these remarkable discoveries, because we really won't be able to get an inventory of the bees of Oregon any other way. So let me just briefly outline how the atlas works before I hand things over to Ellen. Now, there's lots of many initiatives to use volunteers and their curiosity to be able to survey biodiversity. But we were conscious that there were a lot of pitfalls associated with doing this when we started the Oregon Bee Atlas in 2018. The first pitfall is that volunteer capacities are frequently underestimated, resulting in relatively low investment in volunteer training and really narrow focus on basic tasks, such as serving for bees in something like this local park. What ends up happening, we found out in our kind of background research, is a lot of these projects stall under the weight of thousands of new records that aren't real of high-level scientific importance, and they haven't been prepared properly, and information may not be entered into databases correctly, or there are errors. And this results in a bottleneck where we have taxonomic experts who get overwhelmed with a whole lot of specimens and their productivity diminishes. But this bottleneck has a corrosive effect on the volunteers. If you're a volunteer, you're lucky after years pass to get information back on your discovery. More often than not, a discovery disappears down a black hole. When the material is actually kind of someone goes through it, it gets whisked into a scientific publication, and there's not really a thread that goes back to the volunteer's effort. And so volunteers get discouraged, they fall away. And so we were really conscious of this and wanted to get around this, and we decided to invest in developing our volunteers. And we knew this investment was going to pay off because surveys that were performed by our team evaluator, Heather Fisher, showed that 43% of our volunteers had very high ambitions for exploration and discovery. And the sentiment is captured in the unofficial motto of the Atlas, to boldly find the bees that no Oregonian has seen before. We also knew there was a large number of dedicated and well-educated volunteers who are willing to do a lot more than just the basics. A great example of this can be seen in the collection submitted last winter by Ellen Watershed, who was a retired professional with no previous experience with entomology. Not only are her specimens prepared to museum quality, but she took the time to work through 24 monographs on the family Adrenidae and successfully identified most of her bees to the subgenus level. And for this and many other feats, she was awarded our annual Determinator Award. So to determine a bee is to give it an identification. Successes like Ellen's are the product of this intensive investment in volunteer education through a multi-year program we call the Master Melittologists program, which is overseen by Jen Holt and Sarah Kincaid. All new participants are required to complete a self-paced 6-module online training covering topics such as bee biology, database management, survey techniques, and specimen preparation. And this training focuses on practical technique development, includes several interactive activities, such as this pinning assignment shown here, where an instructor can grade the participants' work using uploaded photographs of the volunteers' growing collection. And the key to the training is making sure students understand how to capture records properly. These records, if they're not captured properly, are of no scientific value at all. We use this really innovative workflow where volunteers take pictures of the plant host species, and then in this program called iNaturalist, and we run it through this whole arrangement, and then out the other end pops these tiny little insect labels with all the information associated with each individual bee. And then we supplement this training with in-person training, including our 5-day native bee identification course here, where we really put out the enthusiasm. And combined, this has resulted in volunteers who are really motivated and who work independently and are making some remarkable contributions to our knowledge of the bees of Oregon. The growing scope of these discoveries you can see in these two maps, where the darker shade of blue represents where more bees were collected, and the yellow dots indicate discrete sample events. If you notice, there are not only more bees that were sampled in the second year of the atlas, but these events are increasingly taking place in the sparsely populated, biodiverse, rich eastern part of the state. And our volunteers take great pride, and they also increasingly become people who have their own interests and who are building their own kind of areas of specialization. And this time of year, the collections have come in, our volunteers have been working through them through the winter, and each one of these boxes may have 200, 300 bees in them. And they come to us at OSU where we have our taxonomists work through the bees that our volunteers have identified and confirm the information that they have, information that is on the bees. And if you recall, what I said earlier is the volume of specimens can be a real double-edged sword because they can overwhelm the taxonomic capacity of a taxonomist. Taxonomist, by the way, is a person who knows the native bees and can identify them authoritatively. But here's where this training has really paid off. If you just look at our 2018 data, you can see our volunteers managed to survey an impressive subset of the state's estimated 630 species of bees. Our taxonomist determined 179 species, but as he's sort of worked through, works through all of the bees, we estimate there'll be at least 400 species that were identified in the first year. And our volunteers get information back. So each year they get a little, this is one of our volunteers' work, they get a little map where their bees were collected and a species list. And these bees are the bees that our volunteers are turning up are remarkable. I want to highlight just two discoveries that I think are, really, really high quality. The one on the left, Hoplitis marginata, is newly recorded for the state of Oregon. It's a very rare species that was only known before our volunteers that went out from a few specimens. It's a sedum or stone crop specialists, and our volunteers documented it on host plants on sedum from the Siskiyou Mountains to the foot of Mount Jefferson. And credit goes to Joe Engler and the Grants Pass Atlas team and Brianna Lind. On the right, we have this bee, it's Atoposmia oregona. It's a very rare penstemon specialist, originally collected by one of the faculty here at OSU in the 1950s, and it was never seen since. And Ellen Watershed, who you saw earlier, rediscovered this original population on alpine lava fields visiting penstemon. So I want to, this whole thing rounds out with the Oregon State Arthropod collection. So the bees that are collected, the specimens that are exceptional quality are deposited at the Oregon State Arthropod collection. But we wanted to make sure that you and our volunteers all had access to this information. So we're working on an interactive bee atlas that allow you to roll across the state and then pull up these records and be able to see who generated these records, maybe type in your zip code and be able to get a full inventory of the bees in your area. These records are also uploaded into global biodiversity databases where they can be accessed by anybody as well as researchers around the world. And we just released our 2018 findings. We also get together as a group, this is our annual conference, and do a lot of outreach across Oregon. You see these little cards here, we're at the Oregon Zoo. They can be bended across a popsicle stick with two racers on the ends, an elastic band, and turned into a buzzy toy, highlighting the bee biodiversity in the state of Oregon. But I do want to move on. I was going to ask you a question there, but let's move on to Ellen. When people go through this educational programming, they become certified as a Master Melittologist, just like the Master Gardeners. This is the first program of its kind in the United States. Ellen is on her way to becoming an apprentice level and is going to now tell you about the bees of the Johnson Creek Watershed.
Thanks, Andony. And thanks also to the Johnson Creek Watershed Council for inviting us to speak today. I had signed up to volunteer with the Oregon Bee Atlas well before the pandemic hit. I'm a scientist by training. I wanted to contribute to science, and that's definitely what the OBA is doing. But I had no idea how helpful having something to focus on for the last 12 months was going to be. I don't think any of us did. I really wanted to travel all over and experience my newly adopted state. But just like all of you, I had to stay at home. At least I could collect bees and learn about bees. Andony, if you'll move on to the next slide, that'd be great. Home for me is in the Johnson Creek watershed. I live on Clatsop Butte. That is one of the volcanic domes that define much of the watershed. Our neighborhood drains directly to Johnson Creek, as well as to one of its tributaries, Kelly Creek. So that's where I'm at. That's where I've been collecting bees for the last 12 months. Well, not the last couple months, but last year. Next slide. It has been an interesting year. We moved into our house in early April of last year. And like everyone else, we hunkered down for the duration. Volunteering for the Atlas has been a wonderful distraction. I've not only received the in-depth education that Andony explained to you, which is really satisfying to dig in deep and get into the science again after being a retiree for a few years. And I've learned about the various habitats around Oregon where these bees thrive. I can't wait to get out and travel to some of those habitats across the state. But in the meantime, boy, have my eyes been opened up to the amazing biodiversity that even a small patch of land can hold. Between April 21st to September 21st of last summer, I collected about 400 bees, mostly from my garden, all but maybe a dozen. To the best that my very novice taxonomist eye can determine, they represent 5 different bee families, 15 genera, and at least 22 species. I'm going to say it's going to come in at around 30, possibly even 36, because I am not the expert. Every bee that I have tentatively identified, and those that I haven't identified, will go to our expert taxonomist. And I can't emphasize enough, having that expert taxonomist look at every record is so critical to making each bee collected a valuable piece of science. We learn what flower were they on. This will inform people planting pollinator-friendly gardens, farmers creating pollinator-friendly habitat to not only improve their own yields, but to do good in the environment and so on. And without these vouchered, we have photographic evidence of the plant, we have the expert taxonomist who verifies our identification. Without that specific data gathered all together in one accessible place, all of our efforts would be much less valuable. At any rate, back to what I was finding, I think it's pretty amazing that I've had over 24 species of bees visiting my backyard. Now think about what that might mean for Johnson Creek, for Johnson Creek watershed. My little 0.12 acre suburban backyard has got nothing on the habitat encompassed by the entire Johnson Creek watershed. I'm only touching on the bees in the Johnson Creek watershed. Perhaps in a future year, I can come back and show you a whole lot more. And I'd love to do that. But for now, if we go to the next slide, I can show you a couple that I found in my backyard. Let's start with the bumblebees. Everybody loves a bumblebee, and boy, I sure do. I had no idea I'd find 5 species in my backyard. That was pretty cool. Bombus melanopygus, there up in the upper left on that rhododendron, is one of my favorites. She's just a gorgeous bee with these orangey red stripes across her abdomen and a black tail. Melanopygus, black tail. She's our black-tailed bumblebee. Moving to the right, you see our yellow-faced bumblebee, Bombus vosnesenskyii. You get extra credit if you can say that one right. Right, Andony? I think that's right. I love this bee. It is a common bumblebee. You will find it if you're out there looking around in your flowers. You'll see this bee. It's one of our most common, but I think it's uncommonly beautiful with that sharp yellow single band across its lower abdomen against that jet black. Just a really lovely bumblebee to look at. And it's also, you know, those little mini helicopters that have been buzzing you lately when you go out on a warm day. That's probably a Bombus vosnesenskyii hunting for its first nesting, where it's going to form its colony. And finally, on the right, one of my very favorites, Bombus flavifrons. This is a male. These males started showing up in my garden, midsummer or so. And I got all excited. I thought I had a new species of bumblebee, something new. But yeah, one of the things I learned this year is that male bumblebees don't necessarily look like female bumblebees. This wasn't a new species. I'd already collected some flavifrons females, but boy, it sure was a cheerful lemony yellow bee that I was happy to see show up in the garden once I figured out who he was. Next slide, please. But that's not all, of course. There were so many other bees, so many more genera, and tougher to identify, you know, in a photograph. So I don't have these to species except for this first one. Amphidium Manicatum is not actually a native bee, but it's an interesting, fun bee to have in your garden. This is the male. The males will protect an area of flowers or a little flower patch, and they will chase off other bees, moths, butterflies, anything that comes in there, except for female Amphidium Manicatum. They're protecting those flowers to serve up to their lady friends. The queens, the females of this species, are really interesting. They trim the wool off of plants like lamb's ears, and they use that wool to line their nest cells, hence the common name wool carder bees. I happen to also do a little fiber work. I happen to see that somebody in the audience also does too. So hey, Mona, this is your wool carder bee. Keep an eye out for them and keep them away from your spitting. The next couple bees, I'm not sure their species, but they do show the diversity of bees that we're finding in the Johnson Creek watershed. I love this little tiny bee. It's likely one of the sweat bees, one of the family Halictidae, but that little tiny bee peeking out from that rose compared to some of those great big honking bumblebees it helps you understand the diversity in the bees that we're finding in Oregon. And finally, I love this the little striped, probably a member of the Halictidae family, probably a Halictus, but again, from a photograph, I'm not able to quite tell yet, and the quality of the photo might not even be such that an expert could tell. But it sure is enjoyable to take a look and see what I can see. Next photo, or next slide, Andony. And finally, you know, after being wowed by the diversity of bees that I found last year in my own backyard, I actually have hopes to see even greater diversity in the future. And that's thanks to a Johnson Creek Watershed Council project that's happening right next door to my house. We are so lucky that we are situated immediately adjacent to our neighborhood common space. That's a space that at one time had been planted with native plants, shrubs, forbs, trees. But guess what? No surprise in Oregon, in the last decade or so, without care, had become overwhelmed by Himalayan blackberry. That's a boon to the small carpenter bee of the genus Ceratina. You can see her here nectaring on a blackberry blossom, and you can see a picture of her little nest hole. she will burrow down into the pith of old, dry, dead blackberry canes and make a nice home for her eggs. But it sure does reduce the biodiversity for both plants and animals throughout the space. Well, Johnson Creek Watershed Council was interested in improving this land so that the drainage into Johnson Creek would also improve. When I learned about the project, I jumped at the chance to work with them, and I've been so happy. They've brought in the wisdom of the elders crew, who've transformed the landscape from this blackberry thicket to the open woods that you can see in the after picture. They also have engaged an AmeriCorps crew, and they've been out here several times, and I've joined them to spend many hours digging out blackberry crowns. They just recently started doing some replanting, and it's really exciting to see the difference that we're making already. So I hope to report back to you in the future about really wonderful increases in biodiversity. I also am pretty confident that I've got my exercise program worked out for the next couple decades, because those blackberries will keep trying to come back, and digging them is a great late winter activity to get the muscles and the heart rate back up. I'm also in the summer going to keep collecting those bees and documenting the changes. So I'm committed to helping the Oregon Bee Atlas identify every bee in the state of Oregon. It would be wonderful if some of you would consider joining us in this effort. It's a lot of fun, a lot of learning, a lot of serious science, and that's really what seals the deal for me. With that, Andony, I'll turn it back over to you.
That was wonderful. Thank you so much, Ellen.
Absolutely.
I just want to close with just a couple comments on how you can help. And I'm just going to go right to this. The first one, Ellen already talked about gardening and landscaping for bees. And we do have a brand new OSU publication, which we can put in it's got these beautiful landscape designs and embedded plant lists. You can find it at this link. And so there's some Western Oregon specific plant designs with plants that you can get, including some all native designs. Second thing you can do is if the atlas just seems way too intensive job for you, you can capture images of native bees just in the same way that Ellen did. We may not get the full resolution, but it can be really helpful. And I want to plug an event that that is coming up. Johnson Creek Watershed Council is doing this in conjunction with a number of other organizations. It's going to, maybe we can talk a little bit about it Tiffany can talk about it at the end, but it's a city nature challenge where you go through and you take pictures of all sorts of animals that are around, and you upload it to this program that I talked about earlier, iNaturalist. And we do have a podcast episode, episode 148 of the OSU PolliNation podcast, where John Asher actually talks about how he goes through these records very frequently. And if you go to that podcast episode, you'll see that here are people, these are actual, there's been 125 species identified by picture. There's been 1,500 observers who have collectively made almost 8,000 observations on native bees. And so this is a great way to contribute. And so listen to the podcast and then jump over to the participate in the citywide survey. The other thing is to help the Master Melittologists, and there's a number of ways you can do this. If you're a larger landowner and you have some restored areas, our volunteers are always looking for access onto land, and we have agreements with Forest Service, the land trust like Columbia Land Trust. But if you yourself have a larger property that has some interesting plants, please let us know. We would like to hear from you. You can find us at OregonBeeAtlas.org. That's our website. And so if you need to contact us, you can go through there. We also have a capacity for people to donate, and we're really looking for 3 kinds of donations right now. One is to expand our programming. We're really interested in providing this education to underserved communities, being able to support them through their own independent learning. We think this is really, really a great opportunity for anyone who may not have a STEM background. We have ways to support you and take you through to where you're really functioning at a high level. We have some donations that have been made for special projects. One, a master gardener recently made a donation to help us do some DNA barcoding on this group of bees, the Dialectus, which are very hard to tell apart, even microscopically. And we are gearing up over the next few years to try and create an endowment for a native bee taxonomist position here in the Pacific Northwest, just having this expertise in the Pacific Northwest so that we can keep doing this for decades to come. And with that, I just want to acknowledge we have a number of sponsors of this program, as well as you can see at the bottom, some private individuals who've donated to the Atlas, and we really appreciate their support. And looks like we have a little bit of time for questions. So thank you so much for your attention.
Yeah, thank you so much, Andony and Ellen. This has really been an incredible opportunity to learn so much about the Oregon Bee Atlas. So right now we've got some great questions. If you had questions in your mind that you haven't submitted yet, now is a great time to throw them in the Q&A chat or on Facebook in the comment section, and we'll see the Facebook comments here as well. So yeah, I'm just gonna start off. We have a really good question that starts off looking about taxonomic keys. So the question is it likely that any updated taxonomic keys to Oregon bees and or Pacific Northwest bees will be published as a result of the Atlas work? The Roberts 1973 key to various genera seems to be the most recent we have, apart from plowing through Missioner. I don't know if I said that last name correctly, but yeah.
Well, Ellen, if you might have some thoughts on this, but the one thing I would say is for people who don't know what a key is, it's kind of like a how to identify the bees, and there haven't been recent ones, and there aren't ones that are specific to the region. So there's North American wide keys, and those tend to be very difficult. It would be nice to have keys that exclude the species that aren't found here. We're working on a specific Oregon bumblebee key and a new genera key. There are some, but we are slowly, one of the outcomes of the Atlas is to generate more keys. I will say though, if you don't know the bees of the Willamette, is that what you were going to say, Ellen?
That's exactly
well, then you
what I was
say
gonna
it.
say.
I'll
Yeah,
let you say
yeah.
it.
For a beginner taxonomist, if I dare call myself that, there's a wonderful key by August Jackson. Takes you only to the genus level, but really for a beginner, that's pretty darn good. And he has beautiful pictures. It's specific to the Willamette Valley. It would be the perfect key for people who are trying to get a start into keying out Johnson Creek watershed bees in particular. I used it extensively. We'll provide the link to that so that you can take a look at it. It's a free online PDF. You can also, I think there are some hard copies you can purchase, but you can get it free online.
My sense is that Celeste is a very advanced, is already into this, and I think it is a problem, and I think you well understand that this will take years to be able to develop keys.
Yeah, Celeste actually works with our Watershed Council and has some incredible knowledge. So yeah,
cool.
Thank you for answering that. Also, a side note for folks, we're actually going to send out an email to everyone who's registered for the webinar and a comment for everyone on the Facebook Live that's going to have all the links we've talked about, follow-up email, and things you could do to get connected. If we've mentioned resources that you need details on, we'll provide those too. And also this is being recorded and will be available as well. Another question that someone asked, is there a concern about over collection of bees from this project?
I'll jump in on that one as well. It's a question that every volunteer, I think, to the project has had and has. I ask myself that question, once a week, probably. And I think it through. There are a couple ways to look at it. One is we have collected tens of thousands of bees. Whoa, that's a lot of bees. Wait a second. One honeybee hive might be 30 to 40,000 bees right there. So put that in perspective. There's maybe 70,000 bees that have been collected over the last 3 to 4 years, but that's divided by 600 species. how many months of collecting and how many places, we're getting down to a very small number of bees in any one place. And probably the most important thing well, there are two really important things to me. One is that every bee that is collected is tied to very well documented data. So it's a valuable collection. And then the second one is that for the rare bees, where you'd say, collecting several hundred bees could have an impact, maybe on a very tiny localized population. Well, we don't get 100 bees of the rare bees. We get hundreds of Bombus vosnesenskii and Apis mellifera, the honeybee. And there'll be one or two specimens of the really rare bees. But it takes collecting that many bees to be able to find those rare ones. That said, it's a question that you can bet Andony and Link, our taxonomist, and the other folks who are running the program are going to keep getting, not only from the public, but from the volunteers. It's something that we're keeping in our minds, and we're going to make sure that it won't be a concern.
I'll just add one thing. Ellen's answer was comprehensive and doesn't really require much more. But I will say that the way that we sample predominantly in the atlas is a bee at a time. So there are other sampling methods where people put out these traps that collect a lot of bees. We're doing very kind of targeted sampling, but even where people have done these traps that collect lots and lots of insects, if you think about it, like the data that's been used to show that there's insect decline that's been occurring was a community science project in Germany, was one of the biggest ones, where they would just kind of bring in all sorts of insects, and that's how they could show that there was a decline going on. But where people have looked at those kind of mass trapping studies and compared them to areas where they don't trap, they don't see declines. So the kind of targeted sampling that we do is like orders of magnitude lower. So we really don't have concerns that we're impacting populations.
That's really good to know. Thanks both for that answer. I was wondering a similar thing. Great. Another question someone asked, if you need to do a survey, how do you already know if there's 600 plus species, and how do taxonomists become expert on bees they haven't yet surveyed? This is counterintuitive for this person. That's a good question.
A great question, Carrie. I'll answer this. I don't know how they do this either. This is a little bit above my pay grade as well. What I understand that they do is they look at records from bees in adjoining states, and they say, we think this bee ought to be in Oregon. So that first of all, they pull all the records. The person who does this is the person who gave me that number was the person in Singapore. And so he's got a huge database of all the known records. And then he knows the bees that should be in Idaho, Washington, and California, that should be in Oregon, but haven't been detected. And that's where those numbers come up. So it's a variable number. And the other thing to point out, Carrie, that might not be intuitive is that there's a whole bunch of bees that we just can't tell apart yet. They're kind of clumped together, especially that group that I showed you in the fundraising, the Dialectus. We may have a whole bunch more species there we won't know until we do the DNA work. But it's an excellent question.
Yeah, thanks for answering that one. And the next question we have is from Roberta, and she's asking, are we having problems with invasive bees in the Johnson Creek watershed, where introduced bees are outcompeting native bees? That's a great question as well.
Ellen, you want to answer that?
I'll take a stab.
Yeah, take a stab.
Jump in as well. No, and I think I'm not even supposed to use this term, but I can't remember the term I'm supposed to use. No murder hornets yet, so that's good. I don't want to offend Andony, who's a honeybee expert, but actually honeybees are, non-natives, and they are wild in the state now too. And the question's been raised, are they impacting native bees by competing for resources? If I had to answer that today, I'd say my gut feeling is no from what I've read, but it is being discussed. Even more importantly, bumblebees are being discussed, where there are concerns about some of the bumblebees that have been used for managed greenhouse pollination, perhaps escaping. And is that one of the reasons that the Bombus occidentalis has kind of gone missing in its former range? Correct me if I start misspeaking, Andony, because again, I'm just a year into this.
No, I think we're always getting bees introduced into the state, and so there are, even that wool carder bee is an introduced bee from
Right.
Europe,
Right.
and so the one great thing about the atlas is it's an early detection system.
Yep.
For a lot of these insects. Our volunteers are out and they know what they're looking at, and we'll probably be the first ones to notice if something pops up into the state. And there's a number of bees that we're really worried about. There's one that's loose in Maryland. What's it again? Osmia taurus. It's a very aggressive mason bee, and we really don't want it in the Pacific Northwest region. And I think our volunteers will be the first line of defense to making these detections.
Yeah, and knowing that we have a lot of mason bee nurturers in the audience, ask your supplier where they're getting their bees from. Ask them if they're not getting them from here, ask them to be doing some surveying and really understand if that they don't have these exotic mason bees in their cocoons.
Yeah, thank you both for answering that one. Our last question for today is from Jamie, and they asked some really good questions. So the first one, they wanted to share they're not interested in killing bees, but they want to be a master melittologist. I might pronounce that right, but they would like to help ID bees. They've heard on PolliNation about different ID methods like vacuums and putting them on ice and then photographing or machine learning. Can this person help Bee Atlas using any of these methods or help with farmer surveys of bees using these methods? They also were curious, why do we have to know bees all the way to the species level and a physical record of their bodies in order to do the right thing to protect them? To what extent is this an academic exercise for the sake of academic knowledge alone?
Yeah, that's a great question. I guess the one thing I would say on the last part, it is hard to, I was thinking about Carrie's question of like, how do we know how many species we have? And there is a way in which we are kind of doing an inventory to try and get a listing. And it's unclear to me, like you may have a point. It may be that we actually only need to know the distribution of 12 bees to be able to make, informed management decisions. I don't know this. We do run into a number of bee species that are very, like some of the bees that I was talking about earlier have very restricted distributions and have very specific host plants. And you almost don't know that at the starting end. And I just feel there's so much uncertainty that I would hate to sort of like cut that inquiry short, but it can have that a kind of geek level approach to it. And in some ways, that's what inspires the volunteers in their discovery. Like what we hope will happen is not just bean counting. Our hope is that volunteers, as they kind of get to know the fauna and develop an eye for the fauna, they start to ask more penetrating questions about it. We have a group that became interested in the cactus bees of the Diadasia bees on the eastern part of the state and started to do really the first concerted look at that group. And I'm really heartened by that when people are actually extending their knowledge beyond stamp collecting, because I do agree there is a danger of that, Jamie. In terms of the Master Melittologist and whether you need to create a collection, currently at the apprentice level, there's not a requirement to create a collection. And we have different ways of contributing service. But we are kind of still stuck in this, at the end of the day, our core kind of mission is to get this bee inventory done. And so it's unclear to us, the extent to we want to widen the program out and kind of not do our core work well. So it is an active area of discussion amongst our advisory committee. It's a great question. I don't know if Ellen has anything else to contribute before we wrap up.
I think you put it well that it's the scope of our project. That said, there are other excellent projects like the PNW
Bumblebee Watch, yes, the Xerces
Bumblebee
Society.
Watch,
Yeah.
and even the biodiversity iNaturalist effort that's happening at the end of April. Definitely there are lots of other ways to contribute to the overall effort, but the OBA is about creating these scientifically vouchered specimens that we can be absolutely sure of and even do study 30 years from now. Those specimens will be available to a scientist to look at.
Oh yeah, just on that last point, just quickly, that's the thing I always wonder, I always get amazed by. People use these specimens for questions we can't even think of in the present. So for example, those egg shells that were used to make the case for DDT and bioaccumulation, people collected those eggs for some other reason, but they became important retrospectively in sort of like dealing with a contemporary problem. So thanks for mentioning that.
That's great. I think that gives a interesting depth to this project that I wasn't aware of, you know, all the different factors. I think that's a really good question also, Jamie, and it looks like there are other ways to be involved, and I'm sure Andony could give you more information on that too. So with that, I just want to say a really big thank you for Andony and Ellen, and for the Oregon Bee Atlas, and for OSU and everyone's participation in this community education event. And I just a quick reminder, I will be emailing you. You joined on Zoom. For Facebook, I'll put it in the comments, ways to get involved, follow-ups. I think this is a cool opportunity for folks to jump in. And the City Nature Challenge, I'll put a link for that too. That's coming up as well, April 30th to May 10th. So yeah, anything else before we jump off here?
Just thanks again to Johnson Creek Watershed for improving my neighborhood.
Yes, thanks for doing this great work with us. We really appreciate it. We wouldn't be able to do any of the incredible work without volunteers like yourself, Ellen. So thank you. Thanks again, Andony. We hope everyone has a great day, and we'll see you for the next community education event. Bye. Thanks.
Bye, everyone.